Hi guys, it's Mr. Brian here. In this video, I'm partnering with EduKaji to guide you on the SPM 2023 physics paper. We will be discussing paper 2 today on the structure and assay questions. Without further ado, let's get started. Okay, so this is your 2 hours and 30 minutes paper 2. Let's start straight away with question number 1. Okay, diagram 1 shows a phenomenon that occurs due to the difference to specific heat capacity between land and ocean. Question A, what is meant by specific heat capacity? Okay, I always say that if you do not know the meaning of this, you just go to your formula sheet. The definition is part of the formula. Rearranging it, you will get this. 3 keywords that you must have: the amount of heat you need to heat up 1 kg of substance by 1 degree Celsius. Okay, just put it all together. But truly in SPM, as long as you have these 3 things, I believe you get your mark already. Yeah, we just write it out in a sentence. The quantity of heat needed you can say to raise temperature, to increase temperature also can. To raise the temperature of 1 kg of substance by 1 degree Celsius. 3 keywords. How much heat you need for 1 kg of substance to increase 1 degree Celsius. Okay, part B. Tick in the box for the correct answer. During daytime, does the land heat up faster or does the seawater heat up faster? Okay. Now, one thing that you must know for this kind of land breeze, sea breeze question is the land is very fast. Fast at heating up, fast at cooling down also. Very fast. And the reason it is fast is because it has a small C value, small specific heat capacity, as well as a small. So it takes a shorter time to heat up. And that is something that I tell my students a lot. If you always see that you smaller t here, you have a smaller t, it always means that the C is also smaller. If you have a bigger C value, it always means it takes a longer time. Keyword here is that it is very slow. Okay, and that is the seawater for you. So for the land, very fast. During the daytime, it will be very hot because the sun is hot. Fast at heating up. During the nighttime, it'll be very cold. I also like to say that the land has, or rather the land always follows the surrounding temperature because very fast. So daytime, heat up very fast. Nighttime will be very cold. During daytime, land heats up faster. That's the answer. Okay. And then they ask, what is the reason? Fast or slow is always dependent on the specific heat capacity. You must mention that. You can say the specific heat capacity of land is lower. Or you want to say seawater is higher also can. Than seawater. Okay, seawater higher also can, but you must mention specific heat capacity. That's what controls whether it is fast or slow. Okay, and then name the phenomenon that occurs. Got a few ways lah. You guys can go and look at how the wind is blowing from the ocean. Right, so the breeze is coming from the ocean. Or if you want like the full story of what is going on, because the land is very hot, we say during daytime, the hotter land will always heat up the air here. And just like a hot air balloon, hot air always rise up. But you need to understand, when hot air rises up, somebody has to fill in the gap. This is when the cold air from the ocean will blow in. This is how you get the breeze from the ocean. That's why we call this a sea breeze, because the cold air is coming from the ocean. And remember, the word breeze means cold. You will not have hot air blowing in your face and you call that, oh, I'm feeling a breeze. Yeah, hot air blow at your face, that is not called a breeze. Huh? Breeze must be cold air, and the ocean is cold, the land is hot. You get sea breeze. Okay. Okay, that's all. Question 1. Question 2. The diagram shows the graph of force against extension of a steel spring. Underline the correct answer to the statement below. Relationship between force and extension of spring can be explained by Hooke's law, of course. Yeah, Hooke's law is your F equals to Kx. Ohm's law is your V equals to IR. Okay, this is a simple one. Based on the diagram, calculate the constant of the spring constant. Constant of the steel spring. If you look at your formula sheet, you can pull out this formula. Because since the graph gave you the force, the graph also gives you the x value, and you can find the k value from there. Sorry, my throat is feeling very itchy today. Okay, so we have the force, which is 20 Newton here, and extension is 8 cm. You want to be very careful with the units. Okay, maybe in the working, I write the units. Because at the end, right, it will not be Newton per meter. Because normally we want meter, normally we want SI unit. It would be Newton per cm. Okay, so this is why I get 2.5 Newton per cm. But let's say if you want to do SI unit also can, not to say cannot. Then you do like this. 20 Newton divided by 0.08 meter. Cm to meter, you divide by 100. You get 250. Both are accepted. Both also can. Okay, either one. Huh? That's why final unit is very important. If you have no unit, you lose your mark, your final. Okay, but C1, what will happen to the gradient of the graph if the steel spring is replaced with a copper spring that has the same physical properties? When they say same physical properties, I realize a lot of students, they don't understand this. Like, what do they mean by physical property? That is everything that you can see from the outside, physically. That one is called physical property. So for spring, what you can see are things like the length, the thickness of the wire, and so on. Diameter and all. Okay, physically, they're all the same, just that I changed steel spring to copper spring. I quite like this question because it is actually testing you on two things. Number one, do you know what the gradient represents? Number two, do you know what happens when steel spring become copper spring? So there's two things that you need to know. The gradient actually represents the K value, the spring constant. Hold on, my mouse don't seem to be working. Sorry, give me a moment. Okay, looking at the graph, your y-axis is F, your x-axis is X. When you divide F over X, you're going to get spring constant K. Yeah, if you don't know how I got that, you just rearrange your F equals to Kx. This formula is given, and then F divided by X is K lah, right? Now, please remember that whenever you have a directly proportional graph like that, honestly speaking, in SPM, usually most of the graph, you can use this method. As long as it is y-axis over x-axis, just like how you normally do gradient, y2 minus y1 over x2 minus x1, okay, y divided by x, then we know this represents the gradient, okay, which is the spring constant. Okay. So first thing, do you know that gradient represents spring constant? Secondly, do you know that copper spring is softer? A softer spring always means that it has a smaller K value. Okay, so what happens to the gradient? The gradient decreases. You just need to answer one word. Already got marked. the gradient will drop because the gradient is the K. The K value will drop. And the reason is because copper spring has a lower spring constant. This is the best answer if you ask me. Like you tell them I know gradient is spring constant. You want to add lower lower spring constant, then still spring also can. Okay. Another reason that you can say is that copper spring is softer. You can use the word softer and harder to describe a spring. It is a correct way to describe a spring. Steel spring is harder also can. Okay, copper spring is softer. I feel if you ask me, this is the best answer. Spring constant. Yeah. Okay, there you go. That's question number 2. Okay, question 3. The diagram shows the part of a ray diagram for a convex lens. What is another name for a convex lens? Okay, you can use the word converging or diverging, but in case you forget, convex lens, the shape is like this, and then you have the light enter this convex shape. And then you see, looking at the way it curves, just because it curves like this, it will focus the light, it will it will bend the light inwards. That's why we call it converging. Okay. Meanwhile, if the light enters a cave, okay, another problem that some people might face is like they will ask, teacher, how do I know which one is convex, concave? Wow, if you don't know that, then a bit hard, but I always say, you see the light go into a hole. This hole is like a cave, right? You see the light go into not a hole. This one, the shape is not a cave shape, right? So you need to see the side, which is the left side right now, where light enters into a hole, or light enters into a not a hole shape, like a cave, then you call it concave. Yeah? If it's opposite of a cave, you call it convex. And because it bends outwards, it forces the light to diverge. Okay, this is a converging lens. Okay, then part B. Complete the diagram by drawing another light ray to show the formation of the image. They already drew the easiest one, which is have a straight ray passing through point O. You can also draw a parallel light ray, but I hope you know any parallel light ray will always focus to the focal point. If you draw any parallel light ray, it will always go to the focal point. But one good thing is they already draw the image for you, lah. Yeah, so just make sure you get the 2 light rays overlap here at the image, then can already. Just like that, done. Just draw one light ray only. Okay? If they ask to draw one, make sure you follow, just draw one. There's another one that they can accept. If you draw passing through the F, just now if it's parallel, then you go to the F. But now if you draw passing through the F, then it will become parallel afterwards. It will become flat, horizontal, parallel to the principal axis afterwards. Like that also can. Okay, so you draw either one, just one only. Then part B, part C, sorry, the lens, the diagram is changed to a thicker lens. What happens to the focal point? Okay, this is quite a K-bar question, but a good one. I use a thicker lens. Please know that when the lens is thicker, it will bend more light. Imagine the light enters a very thick lens. You will need to pass through a very thick glass, for example. And so as a result, it will bend the light even more. So if you have very thick like this, imagine light will go in and then it will bend it a lot. Okay, but if you have thinner lens like this, light will go in, but then it won't bend it so much. Maybe something like that. Okay. Or maybe I draw 2 light rays to show you. Okay. The question is asking what happens to the focal point. From here, you can see the answer already. If it's a thicker lens, the point it will focus is closer. Focal, they ask for focal length. Focal length is from here until here. Right? If it's a thinner lens, then it's like that. It will focus further. Because the light won't bend so much. When I say won't bend, that means it will, like, if it's totally straight, that means it will not bend at all. But you know that doesn't happen if you have a lens, right? So if you have a lens, it will bend a little bit, but how much depend on the thickness. The thickness also controls the power actually, which is not really in your syllabus too much. But normally, thicker lens is higher power one. Normally, thicker lens is higher power. So this is something you all need to know. It's getting more and more popular these days. The focal length decreases. That's the answer. You can say decrease becomes shorter also can. Okay, then they ask, state the size of the image if the object remains at the same position. Now that you've said focal length decreases, meaning this F now maybe come over to here, decreases, become shorter. And then this 2F also become much shorter. Maybe come to here. But then the object remains at the same position. That's something you want to be really careful of because usually when I discuss this, many people they don't get the meaning of it. At the same position, I do not move the object. I only change the F and the 2F because the lens changed to a thicker lens already. Okay. Now I can redraw the whole thing for you lah if you want. So imagine now you have a even thicker lens, let's say. Okay. And then let's just say here is F, here is 2F, right? But my object is still pretty far away, you know? It's quite far away from the 2F. It still remain there. Okay, you understand what's going on, huh? Object is still here. But then the 2F move over to here already. Closer to the lens. The F also move closer already. We try and see to do our drawing, just to prove to you. If I got a straight ray like this, and also a parallel light ray. Oh, I forgot to draw the F here. Okay. Can you see that the image is much, much smaller? At first, the image is quite big one. It's like quite far away. Okay, but remember that the closer your image is to your lens, the bigger it is. Sorry, the smaller it is, my bad. If it's very close, it is small. If you go form bigger and bigger and bigger, it will be bigger, bigger like this. It will become bigger and bigger and bigger if it's further. The original one is bigger because it's further. The one right now is smaller because it's closer. Answer is decreases. Or you can also say changes to the size of the image becomes diminished. Or you can say becomes smaller. Also can. The easiest answer is that you say decreases lah, right? So what happens? This question is really not easier. Yeah, they're asking you at the same position. Right now, your object, if you notice, has now already become u greater than 2f. The distance is further than your 2f. Originally, the object distance was at u equals to 2f. Okay, and those of you who are very pro at your image characteristics, you know that if this is your lens, let's say this is f, this is 2f. If your object is right here, further than 2f, you're always going to get a real inverted diminished characteristics of image. At 2f, you're going to get real inverted same size. Yeah, that is the difference. Do you notice this was same size? Do you notice this is diminished from the object to the image? The object to the image has gotten much smaller. It will become smaller one. Okay, and then part D, an object is placed at a distance of 12 cm from the optical center. A real image is formed at a distance of 9 cm. Calculate the linear magnification. Now, this object distance is the U value. This image distance is the V value. Okay, linear magnification, you can just do V over U. Don't worry lah, if you forget, formula is there. They give you the formula also. Then this one, V over U. Okay, so this is the easy part actually. 9 cm over 12 cm. And magnification don't have negative sign one. You do not need to put any negative sign for magnification. You only need plus and minus sign for thin lens formula, if you know what I'm talking about. Guys, we don't want 3 over 4, I want 0.75. In physics, we do not like the fraction. Always leave your final answer in decimal, please. Okay, or else they'll mark you wrong one, be careful. You get 2 marks for this. Okay, and then some people will ask, teacher, can I do it meters? Can also. You're gonna get same answer. The meter and meter will cancel, just like the cm and cm will cancel. That's why at the end, you should not have any unit. It will still be 0.75. Okay? Okay, done. That's question number 3. Then we move on. Question 4. The diagram shows a transistor circuit that functions as an automatic switch. Okay. Name the type of transistor K. This is a NPN transistor. If you do not know how to see, you can write NPN, no problem. You want to write big letters, you can NPN, it doesn't matter, right? You want to write NPN, really, don't be paranoid, it doesn't matter. Okay, if you don't know how to see, you just look at the arrow. The difference between NPN and PNP is just one arrow point down, another one, the arrow is pointing up. The arrow represents current flow. Current must always flow from positive to negative. And what terminal would be this? It has to be alternate NPN. If you see the arrow go up, then it's P down here and up here. It must always flow from positive to negative. Positive to negative. That's how you decide. Quite popular, this kind of question. Make sure you know. Quite simple. Part B, explain how the bulb in diagram 4 can light up in the dark. Okay. This concept is something that is difficult for many people. You have to know one thing at first, that when it's dark, the resistance of the LDR is going to drop. I always tell my students, if it's cold or nighttime meaning dark, resistance always drop. Okay, of course, right now we are not talking about the cold. Cold is for the thermistor. If it's cold thermistor, I'm so sorry, I made a mistake. Resistance is going to go up, increase. Thermistor resistance will increase. If it's nighttime, LDR resistance is going to increase. Okay, then you also have the opposite, which is opposite of cold is hot. Opposite of night is daytime. So hot day, all the resistance for thermistor LDR will fall down. Okay, right now I'm talking about thermistor or LDR only. Resistance is going to go up. Now, when resistor goes up, because it's nighttime for LDR, voltage here will also increase. Please understand that the battery is going to first share the voltage between these two resistors in series. Can see? You ignore the transistor first. The battery, 18 volts, will share between these two resistors. Don't forget, in a series circuit, voltage will share one. Right? Series circuit current is the same, but the voltage is going to share. Like maybe this one is 8 volt, for example. Then this one is maybe 2 volt, 6 volt, something like that. But it will share. But in total must still be 8 lah. Okay, you get the idea. So because the voltage, because the resistance is higher, it will get a larger share of voltage. How come? It's because these two guys, they always have the same current. Series circuit current is the same. So you think like this. If the current always the same, how to get more voltage? If you have a bigger resistance, then you will have a bigger share of voltage. Okay, because current is the same between these two. If you have a bigger resistance go up, then you will get a bigger share of voltage. That's how we do it. So always remember, for this kind of automatic switch circuit, higher resistance means higher voltage. Lower resistance means lower voltage. You will get a bigger share out of the 18. 18 will split. It will not. It doesn't always have to split 9 volt, 9 volt. It can be any splitting. The moment voltage down here increase, your goal has achieved, because the base voltage increase is your goal. This is always your goal. Base is the one down here. You always want your base voltage to increase. If it doesn't increase, then base current is not going to flow. Then transistor is not going to turn on. Then collector current is not going to flow. Okay, the moment, I repeat, the moment base voltage increase, this blue color one will start to flow. If it's not high enough, it will not flow. So the green color one you have to see first. Then only the blue color one, number 2. Sorry, you can see now. Number 2. If the blue color one flow, transistor will turn on. Then only the orange color one will flow. It's step by step one. Green color one first. Only when base voltage is high enough, base current will flow, number 2. Then only collector current will flow. Then only the current is going to split from here, and then it's going to flow in like this. Then the bulb will light up. Okay, so it's step by step. How does the bulb light up? It starts with number 1, talk about resistance. Resistance of LDR increases in the dark, or when it's dark. Or sometimes people will say when light intensity is low. Also can, in the dark or light intensity is low. You already get 1 mark. Because resistance increase, down here, the base voltage increase. We only call the bottom part base voltage. The on top one is not called base voltage. It depends on the bottom part. This bottom one is base. Okay, base voltage increases. When that happens, base current flows. Transistor turns on. And then collector current flows. Okay, any 3 out of 5 you got correct, you get full marks. The answers are very short. Notice the sentences are very short. I'll write exactly like this in SPM. But I hope you can understand the whole flow, like what I explained earlier. Okay, we move on to part C. The resistance of the LDR in the dark is 50 kilo ohms. Calculate the voltage across the LDR. Okay. Right now, they say voltage of LDR 50 kilo ohm. Find the resistance of LDR. Hey, I'm so sorry. Sorry, a little sick enough today, so a bit brain fog also. Okay, so the resistance is 50 ohm. Find the voltage. Okay, all right. For this kind of question, I always say you have to understand this green color concept. You have to understand this series idea that the voltage is going to share. How does it share? It depends on the ratio of the resistance. If, let's say, just to give you an example, if let's say this is 2 ohm and this is 6 ohm, this is the reason why, because it is 2 ohm and 6 ohm, the voltage is going to share according to the ratio of the resistance. So if it's 2 to 6, voltage also will be 2 to 6. Of course, I give you all simple numbers to help you imagine, but it will follow the ratio. Okay, it will follow the ratio. So your job is to go and write a few ratio. Yeah, your job is to go and write a few ratio. Okay, I want to find what is the voltage of LDR. And I know the resistance is 50 kilo ohm. Okay. Also, they always like you to go and write the voltage, the total voltage. If my voltage is 18 volts, which is the total, question, what is the total resistance? What is the total resistance? How do you add resistance in a series circuit? Like this one is what? Total resistance is 2 plus 6 ohm, become 8 ohms. 8 ohms is same ratio as 8 volts. 2 ohm, 2 volts. 6 ohm, 6 volt. Okay. The total voltage is 18. The total resistance is 10 plus 50. 10 kilo ohm plus 50 kilo ohm. Can see? Some people also ask, teacher, what about the voltage at this R2? Let's call it R2. I don't know. But if you know, you can also write as one of the ratio, like the voltage of R2 with a resistance of 10 kilo ohm. Can also. So there's only 3 ratios that you can possibly write. Guys, remember, number 1, you can write the ratio for V and R here. What is the V? What is the R? For right here on top. Number 2, you can write the ratio of the V and the R for the thing at the bottom. What is the V? What is the R? Or number 3, you're going to also write the V and the R for the total voltage and total resistance. Total is 18. Total resistance here is, you just add up all together. In a series circuit, the resistance you just plus. Okay, it's like this concept. Ignore the transistor. Forget about the transistor. Just focus on the green color part. Okay, just focus on the green color part. Also, one more thing, guys. Normally in SPM, they really want you to write one of the ratio as the total. They quite like you to follow this format that is in the textbook. Honestly, you don't have, you will still get the same answer one if let's say you use this ratio and this ratio. But somehow the mark schemes normally prefer you to write one of the ratio as the total ratio. Meaning to say, you choose this one or this one to write first. And then the other ratio, you choose the total ratio, the 18 volts to write. Okay, I just need 2 ratios. The next thing is you just copy and paste into a fraction. You just write V over 18 equals to 50 over 10 plus 50. I show you. Done. You just need to write the ratio to ratio as a fraction. Then you can solve it, just like that. Ten plus 50 is 60. Can multiply the 80, go up. 18, sorry, go up. That's your answer. 15 votes. Okay, 15 votes is the answer. And I got one more question to ask you guys. If I got my voltage for LDR is equals to 15 volts, what do you think is the voltage for R2? Answer must be 3 volts. Why? Because 3 plus 15 must be equals to 18. They must be equal. The voltage will share between these two. If they ask lah. Okay, this is the answer C1. Part 2, calculate the current flowing through the LDR. Current flowing through the LDR. Now you have the resistance at the LDR, you got the voltage of the LDR. I don't think so it's a problem to find what is the current at the LDR. P equals to IR. Okay, so I do here. All this is for the LDR. So the voltage is 15 volts. Current I want to find. Resistance, must be careful. They like to use kilo ohm one in this topic. Kilo ohm and normal ohms is not the same. So if you sub 50 alone, then GG already. You have to change the kilo to multiply 1000. And 50 kilo ohm is 50,000 ohms. Then you divide over. I get 15 divided by 50,000, 3 times 10 power negative 4. Okay, you can leave that in amperes. That is the same as 0.0003 ampere. Because everything SI unit, final answer also will be SI unit. If you never change them wrong already, you have to be careful. Okay, this is the answer, 0.0003. Either one also can, 3 times 10 power negative 4 also okay. Right, that is question 5. The diagram 5.1 and 5.2 shows pattern of water waves after passing through slits with different size. The wavelength and frequency of the incident wave are similar. Okay. The wavelength and frequency for the incident wave. Incident wave, that means the wave before it enters the slit is similar. What name the wave phenomenon, sorry? It's called diffraction. Diffraction means spreading of wave. Okay, diffraction is fine. You want to write diffraction of wave also can. But the of wave is optional. I put in bracket. In bracket meaning optional. Then observe the two diagrams. Compare the size of slit. Diagram 5.1 has a bigger slit compared to 5.2. In SPM, you can write like this. But in school exam, some teachers, they want you to go and copy size of slit for diagram 5.1 greater than 5.2. Yeah. But in SPM, if you write exactly like that, it's fine. Because why your teachers want you to copy is because in essay questions, you must copy. Okay, for essay questions, your answer is separate one, you have to copy. But structure question, you can just write like this because the question is right on top. So, okay. And please double check with your teacher. Some teachers, they don't want to accept this in school. They don't want to accept the greater than symbol. Then you write, it's greater than. But guys, in SPM, both also can. If you're paranoid, you want to write the words, go ahead. If you want to write the greater than sign, go ahead. Is greater than, is smaller than, is equals to. Yeah, just 3 words only for each symbol. Next one, the amplitude of wave after passing through the slit. The amplitude actually is the displacement. You cannot tell from the first picture, but from the graph you can tell. The displacement tells us how high the water wave will go, how high and how low it will go. Yeah, and in this case, the amplitude is 1 for this. This one, the amplitude is 0.6. Okay, also one very important thing, I'm not sure if they will ask this later. Lower amplitude means lower energy. Lower amplitude meaning the wave don't go very high. And the reason why the water wave don't go very high is because it has less energy. Must know these two, they are best friends. Yeah, they're always together one. Lower amplitude always means lower energy. And that is what diffraction does. Diffraction will help you to reduce the energy because you are forcing the wave to pass through such a tiny hole, a tiny slit. Only this much of wave can go in. But as a result, you get this much of wave. Okay. So diagram 5.1 is greater than diagram 5.2. Diagram 5.2 smaller also can, up to you. Okay, the spreading of wave after passing through the slit. Which wave spread more? Diagram 5.2 spreads more. How do I know? Because you can look at the angle of how far it spread. Spread means how wide does it go? This one is spread like this. Yeah, so the one that is usually very curvy, that is very curvy. You see the first picture is very straight, the wave. The curvier one is weaker. It spreads more because the hole is very small. That's why it will spread outwards more. If the hole is very big, it doesn't want to spread one because the wave is very strong. There's so much wave that go in, it barely spread. This is what you get. So the idea is you put a big hole, a lot of wave go in, it is a very strong wave, it will not bend for you, it will be straight. But if you put a small hole, a little bit wave can go in only, it will become quite weak. The moment it is weak, it will spread, it will curve outwards. So spread is because it is weaker, the energy is lower. Okay, can. So you can say the spreading in diagram 2 is greater, or the spreading in diagram 1 is smaller. Usually, we also like to say the word more or less significant for spreading. Diagram 5.1, the spreading is less significant. Or you can say less obvious also can. Also can, either one. Or diagram 5.2 is more significant, spread more. Diffract more, also okay. Okay, then relate the size of slit and spreading. It looks like if we refer to the previous answers, size of slit in diagram 1 greater, then the spreading will be less. You can say the greater, the smaller. Yeah. The greater the size of the slit, the smaller, or there's an even better word, the less significant. The spreading of waves. Okay, amplitude and spreading. They ask you to read it. You see if the amplitude is smaller, it will spread more. Or you want to say if the amplitude is bigger, it will spread less. Up to you. Okay. The greater, you can say one up, one down. So maybe if I use the second picture, I can say if the amplitude is smaller, then the spreading will be greater. Or the other way around also can. So like the lower or the smaller the amplitude, it doesn't matter one. You can say one up, one down. It doesn't matter who is smaller and who is higher. The greater the spreading of waves. Or the more significant the spreading of waves also can. Okay. Then part D, why the amplitude of wave changes after the water wave passes through the slit? How come the amplitude will be not the same as before? Maybe before that the amplitude was like 12, sorry, not 12, 1.2 cm. After it spread, it only becomes 0.6, let's say. Like the wave at first very high, but after it passes through the slit, it becomes very low. Why amplitude low? Always talk about amplitude's best friend, because energy is lower. Okay, that's the answer. Done. There's only one best answer, because energy decreases. Okay, then part E. The diagram shows a flood siren system used to give warning to the residents, the housing area. Sound produced by the speaker is not able to be heard clearly by the residents in the housing area. What is the change that needs to be done on the frequency? Okay, explain. What do you want to do to the frequency of the wave to overcome this problem? This is a very good K-bar question. Guys, our goal is I want the wave to spread. Right now, I cannot hear the sound clearly. The house is very close to the loudspeaker. To the loudspeaker, but I cannot really hear. The reason is because the wave is too strong. It only travels straight. If you want the wave to spread, if you want diffraction to happen, then you need to have a lower frequency wave. So the weird thing is, if the energy of wave is lower, it will spread more. And when it spread more, then it can cover more area. So there's two goals. Do you want the wave to spread more, wider? That means you want diffraction. You want a lower energy wave. Or do you want the wave to go very far? Like, some of the waves, you want it to go to until like outer space to the communication satellite and all that. That one you want high energy. Because it needs to go very far. You don't want it to spread. You want it to go straight and far. So there's two types. Okay, for this one, you want it to spread. You need to choose a lower frequency wave. You can say decrease the frequency of wave. They ask you what should you do to the wave? I want to decrease the frequency. Reason, because when you decrease the frequency, it will diffract more. Waves diffract. Waves diffract. Or you want to say spread also can. Diffract and spread is the same meaning. More. Or you want to add sound waves diffract more, spread more, also can. There's another answer that we accept as the explanation. Because the wavelength increases when frequency decreases. If you want any wave to diffract or spread more, there's two ways to do it. Number one, you make the slit size smaller. You make the gap smaller. Why? Because when the gap's smaller, less wave can enter. It becomes weaker. So you want to diffract more, to spread more, you always think, I want to choose a weaker wave. I want to find a way to make the wave weaker. Make the size smaller, because the size smaller, then less wave can enter, then it's weaker. Weaker, then it will spread more. Another one is, you want the lambda to increase. When lambda is higher, it always means that the wave is very chill compared to this kind of wave. This kind of wave very intense. Okay, so bigger lambda always means that it can spread more. And how to make the lambda bigger? You can make frequency smaller because of V equals to F lambda. When frequency small, lambda will be big. Okay, that is the answer. Right, it's a very good question and many people couldn't score it. They go and say, I want higher frequency, then higher penetrating power and all that, higher energy, That's wrong. I do not want that. I do not want higher penetrating power. I do not want higher energy and all. I want it to spread further. Okay, so don't answer the wrong thing. That is question 5. Okay, we continue with question number 6. A current carrying conductor, which is placed between two bar magnets, a catapult field is produced. Mark the direction of the force on the current carrying conductor in diagram 6.1. Now, Mark the force. You're trying to find force. I always tell my students, if you do not know whether this is Fleming's left hand or right hand rule, you just write out 3 letters, FBI, and ask yourself, what are we looking for? Clearly, the question also say, find the force. Yeah? You got magnetic field. B is the magnetic field. You got current flowing in the current carrying conductor. Current carrying conductor just means a piece of wire that carries current. A piece of wire that got current. Yeah. So if you're looking for F, and guys, F is on the left side, then you use your left hand. If let's say you're looking for current, right? Then you use your right hand. This is how you decide. Looking for F on the left, looking for I on the right. So you're gonna do one by one your finger, your index finger, starting from north point to south, this. And then your current finger, your middle finger, is going into the page. This is the eye going into the page. Your thumb will naturally be pointing upwards. Okay, don't follow my video because sometimes the video will flip and all, and it might be a bit. Oh, I'm so sorry. I made a mistake. It's not upwards. Okay, let's do it again. Sorry, the index finger is pointing this way. Current middle finger is going into the screen. I'm getting my thumbs down. Okay, sorry, the answer is thumbs down. The force is acting downwards. This is the direction of the force. Okay, done. Remember, one by one, north to south, your index finger north to south, which is pointing, I'm following the screen. Don't follow my video because it can be a bit confusing. You can follow the screen or follow the paper. Point to south. Current is going in, middle finger, going into the screen, into the page. Thumb will naturally be pointing downwards. Okay, a bit hard to see, I know, but thumb will naturally be pointing downwards. This is what I got. Part 2, define catapult field. Catapult field is the resultant magnetic field that you get. I hope you all know that when you have magnetic field from a magnet and also you have magnetic field from a current carrying wire, they will interact. And that interaction gives you what we call a catapult field, which is also what gives you the force eventually. Yeah. So magnet got magnetic field. Any piece of wire that carries current will also have magnetic field. They interact, you get catapult field. Catapult is the resultant magnetic field of interacting these two. Resultant magnetic field produced by the interaction between the magnetic fields from the permanent magnet and the current carrying conductor. A bit long, huh? But really, you are just trying to say the resultant magnetic field produced by, keyword here is interaction of two different magnetic fields. They interact, they mix together. Okay. But B, diagram 6.2a and 6.2b shows a simple experiment of an electromagnet. Observe and compare. They ask to compare number of turns of coil, potential difference, and speed of rotation. Okay. Number of turns of coil, 10 turns, so it's the same. Voltage, 1.5 and 3. And then rotation speed, 2 rotation per second versus 5 rotation every second. Okay, so it's less than, the green color one is equal, the orange color one is less than that. Okay, so you can answer one by one. Number of turns of coil, diagram 6.2a is equals to diagram 6.2b. Okay, number of turns of coil the same. Potential difference. Diagram 6.2a is smaller than diagram 6.2b. 1.5 is smaller than 3 volts. Lastly, speed of rotation. 2 rotation less than 5 rotation, of course. 6.2a less than 6.2b. Okay. Remember, however, I answer in right here is how you can answer in SPM also. Yeah, but I know some school exam, like I always say, it depends on your teacher, because some teachers, they don't like the symbols, maybe. Yeah, you ask your teacher if they like the symbols. Or some teachers, they will say, even in structure also, I want you to copy this question and write here. In SPM, don't need. Yeah, but for, like I say, essay question, you need to copy the question. You have to say the potential difference in diagram 6.28 smaller. Yeah, structure don't need because the question is right on top already. Okay. Okay. Then, based on part B, state the relationship between potential difference and speed of rotation. If potential difference is smaller than speed of rotation, or smaller, or if it's greater, then it's greater. Up to you, either one. Okay. Maybe I like to say greater. Maybe you can say that. The greater or higher also can. Or you want to say increase also can. As the potential difference increases, speed of rotation increases. The greater the potential difference, the greater the speed of rotation of coil. Okay, then potential difference and the force. The greater the potential difference, confirm the greater the force. Because the force is greater, therefore, it will spin more rotation in 1 second. The reason why it can spin so much is because it has more potential difference, then more force, then it will spin faster. Okay, so greater again. Or increase also can. The greater the potential difference, the greater the force. Okay, then part B. The dry cell in 6.2a is replaced with an alternating current power supply with frequency of 50 Hz. What happens to the rotation of the coil? Give one reason for your answer. Okay, what happens to the rotation? So alternating current, that means the current keep on changing direction. That's alternating. Direct current comes from a dry cell. If you have a battery, the current always flows the same direction, let's say, and it always spin the same direction. The force you get is always the same direction. Now, you can also look at this picture. Imagine suddenly there's alternating current, meaning the current won't always flow the same way. If current flow like this, I know I will get force down. But alternating meaning the current will flow like this and like that, like this and then like that, and it will change 50 times in 1 second. That's what 50 Hertz means. So keep changing back and forth, back and forth. You do your Fleming's rule also, it will keep on spinning up and down, up and down, up and down. The force will keep on going up, down, up, down, up, down. Yeah. So what happens to this coil? It will not rotate. It will just vibrate like that. Yeah, it will just vibrate. You want to go up, down, up, down, up, down, very fast. It will just vibrate on the spot like this. Okay, this is what happens when, because normally alternating current is minimum 50 Hertz. 50 Hertz meaning it will vibrate 50 times in 1 second. Yeah. So we will say that, oh, it vibrates or it does not move, or you want to say stationary also can. The coil vibrates. Or the coil does not rotate. Okay. Or the coil remains stationary also can. Does not move also can. or you want to add and be more specific, vibrates on the spot. Like it doesn't move, you just vibrate like that. Because it got the force up, down, up, down, down, up, down. Okay, so the reason is you go and tell them that your current change direction, your force also will keep on changing direction non-stop. The direction of force constantly changes direction. Okay, or you want to say the force, got many ways to explain it, but as long as you talk about force keep changing or keep reversing direction, also can. Yeah, got a few ways to answer, but you must talk about the force for your reason. That's why it just vibrates. But quite a good question, this one, huh? We look at question number 7. Diagram 7 shows a communication satellite orbiting the Earth and remains at a height of this from the Earth's surface. The radius of Earth is this. Name the force that keeps the satellite in its orbit. Centripetal force. The force that always makes sure something orbits round and round in circle is centripetal force. Okay. Can I say gravitational force? Sometimes they accept, sometimes they don't accept. Sometimes they accept, sometimes they don't accept. The second best answer is gravitational force. Yeah, because understand that centripetal force looks like this. This is how I would label if they ask me to label. It's the force that keeps on pulling the satellite to the center. Keeps on pulling it like this. That's why, because satellite is moving quite fast, right? And then it keeps on pulling it to the center. So end up, it will go round and round in circle. But please also understand, this centripetal force comes from where? Gravity. It's also the gravitational force. Right? So centripetal force and gravitational force is the same thing, actually. I always say they are the same. But specifically to make things orbit round and round, the best answer is centripetal. Yeah. In this SPM, they also mark correct if you write gravitation. But it depends on that year and the mark schema. But B, calculate the radius of the orbit. They gave you the radius of Earth. They gave you the height. Radius of the orbit, meaning how big is this circle? You just add them up together. What is the total from here until here? Radius of orbit is what we commonly known as small letter r. Yeah, radius of Earth is what we commonly known as big letter r. Okay, so you just plus both together, then done already. It's just 1 mark only, so but be careful, the unit will be km, which I think is what they expected, so they put km here. Okay, because they put km, you don't have to put km anymore. Then part 2, linear speed of the satellite. Okay, so far information that you have is that it is r. Let's take a look at formula sheet. Okay, hold on, it's loading a bit. For the linear speed, normally I'll go and use this. Yeah, normally we use this, but you notice not, they did not give you the mass of the Earth. You have the R value, but they did not give you mass of the Earth. But a lot of people don't know, right, that if you cannot use number 8, you can also use number 5. They're actually calculating the same thing. Both of them are trying to calculate the linear speed. Okay, right now you have the R, but in this SPM question, they didn't give you the T, but they mentioned something very important. So this is quite key, but they mentioned communication satellite. If they mention communication satellite, it must be geostationary. I hope you know that in your syllabus, there's only one type of satellite that requires it to be geostationary. That is communication. You must know that. Everything else other than communication is non-geostationary. For example, GPS satellite, non-geostationary, weather forecast, Earth imaging, all this, except for everything other than communication is non-geostationary. Okay, and if it's geostationary, meaning as the Earth rotates, the satellite always need to follow exactly on top of the same location, always above the same geographical location. For example, the satellite must always be on top of Kuala Lumpur, KL, always. So Earth is rotating, but the satellite will orbit and follow like that, which means it must always be a period of 24 hours. The question didn't tell me this, but I already know the period. Yeah. I did remember that year, quite a number of students, they asked me, teacher, they didn't give mass of Earth. Then I don't know how to do it. Was there a mistake or whatever? No, because if you cannot use this, you can still use number 5. This is a KBAT that actually is testing you. Do you know the period is 24 hours? Okay, so this is what I'm gonna do. I can't do this because I don't know what is mass of Earth, and they do not need you to memorize mass of Earth. If they want to give you, they will give you, unless it's really a mistake. If they want to give you, they will give you. You're not expected to memorize it. Okay, I cannot use this because I don't have time. Mass of Earth. Sorry, but I can do 2 pi r over t. Okay, but a few things lah. The r value, I'm gonna do this one, but I'm gonna change km to meters. Km you want to do times 10 power 3 can. If you don't like, then you multiply by 1,000, become 0, 0, 0 like that also can. Okay, up to you. Over t. The period also you want to be careful. Yes, it is 24 hours, but hours you should change to seconds also. Every hour got 60 minutes, every minute got 60 seconds. You can multiply 3006 also. 60 times 60 is 3600. And so the V value would be. Just use the pi in your calculator. Don't need 3.142. This is what I got. Okay. We do 3 decimal. Okay, can. So quite key about this one actually. Then we move on to part C. Diagram shows 3 different satellites. They ask you communication satellite again. And then used by telecommunication agency. So even if you've forgotten that communication needs to be geostationary and all that, this question is very kind. Immediately in the next question, part C, they ask you for communication satellite. And so you know you're going to choose geostationary, which has to be 24 hours. So that will remind you that, oh, I forgot already in part B, but never mind. They are reminding you again the period must be 24 hours. That's how you are able to solve part B. Can So answer is clearly P lah. We're definitely going to choose P. Okay. So type of satellite, geostationary. Just copy from the table. Don't need to change anything. Table right, geostationary, you copy. Reason, because it is always above the same geographical location. Always on top of KL, for example. Okay, got many other answers that you can say, but if you ask me, this I feel is one of the best reason. Right? Got other things that you can say, it means that the orbital period is always 24 hours. Because geostationary will always make sure orbital period is 24 hours. And by the way, communication satellite, you need it to be geostationary, or else it will not work. If you want live TV broadcast, let's say you are watching your badminton match, your football match. Sorry, I want to draw Earth. Okay, badminton match, football match. Let's say the badminton match is happening in, let's say, Spain or Portugal, whatever. And this country need to send the signal to a satellite, and I need to know where the satellite is. So it must always be above the same geographical location. I must always know that, okay, maybe this satellite is always on top of Kuala Lumpur, so that I know where to send the signal. And then from this satellite, I will send to your household. This is how you watch it from Malaysia, let's say. So I can have live Olympics, live badminton match, football match from all around the world. Doesn't matter. I will send the signal to the satellite. I need to know where the satellite is. It must be geostationary, maybe always on top of KL or whatever, so that from the satellite, it can send down the signal to your country. That's how you watch the live matches. That's why communication must be geostationary. If it's GPS, weather forecast, it doesn't have to. For GPS weather forecast, the satellite needs to move around to watch the Earth, to see the traffic of the Earth, to see the weather of the Earth, the weather changes. So it has to move around. It cannot be geostationary. Okay. You can also say it is orbiting the Earth same direction. Orbiting the satellite is orbiting the Earth same direction as Earth's rotation. Okay. Orbital period is 24 hours. Another way to say this is orbital period is same as Earth's rotational period. Also can. Earth's rotational period. Remember, the Earth is rotating, but the satellite is orbiting. Different words. Earth is rotating, but satellite is orbiting. Okay, next one. Orbital period, I want 24 hours. So that it is same as the rotational period of Earth. Or you can say, so that, can I cheat a little bit? I copy this sentence. It is always above the same geographical location. Also can. Right? I want to warn you of something. Normally, normally we will say, I want a higher orbital period or lower orbital period, because most of the time we avoid writing the numbers. Right? If you have done enough trials paper before, you will know what I'm talking before, or SPM past year, you will know what I'm talking about. In the format, we do not teach them what to do. You don't have to tell them, I want 24 hours or what. But this is a special case. You cannot say, I want a higher period. You'll be marked wrong. You have to say, I want exactly 24 hours. Because for it to be geostationary, it must exactly be 24. Can it be 23 hours? Can it be 26 hours? Cannot. It must be exactly that value. So here's the thing. If you don't write the number, it changes the meaning. Sometimes certain things, it has to be exactly at that number. Then only it will work. Right? If it's a bit higher or lower, cannot. Don't say, teacher, but in this table, this is the highest value. Can't I just say higher? Cannot. It has to be exactly 24. Higher, how high you want? 36? 48? Yeah, so it has to be 24 for this one. Huh? And the answer is satellite P. You can just write P. You can write satellite P also can. Okay, that is part D. Question 7. We move on to question number 8. Okay, the diagram shows an electric circuit containing several dry cells with electromotive force, e.m.f, of 6 volts. Internal resistance is 2 ohm. What is meant by electromotive force? Electromotive force you want to explain is how much work done or energy to move 1 coulomb of charge by the battery or by the dry cell in the whole circuit. Okay, quite long this one. The work done. You don't want work done, you can also say energy. Okay, either one. By the dry cell is the electrical source. Sorry. electrical source, that means the battery, to move 1 coulomb of charge. Charge is Q. 1 coulomb is the SI unit. Huh? To move 1 coulomb of charge in a complete circuit. Okay, how much energy you need to move it through the whole circuit? Whole circuit, that means not only passing through the wire, no, including the battery also, the whole thing. Okay, then calculate the ammeter reading. We have so far e.m.f is 6, R is 2 ohm, R we don't know, and then they want you to find I. Okay, whenever there is a small letter R, internal resistance involved, there's only one formula that you can use for electricity. That's this one. There's only one formula. Only this formula has small letter R. All the other formulas, they do not have small letter R one. So only this one has small letter R. You can use that. Okay. But then, okay, so I move my information downwards. But then you will notice that you do not have the big letter V. But no issue, because big letter V is also the same thing as V equals IR. Okay, so you can go and replace IR plus IR like that. Yeah. So you sub in e.m.f is 6, current is I, R you don't know. Internal resistance is 2. So you would think, oh no, we have 2 unknowns. Big letter R, I don't know. Big letter I also, I don't know. Right? Then you might be thinking like, oh, is there any other way that I can find out the big letter R first? Actually, unfortunately, no. There's no way you can find big letter R first. If you do V equals to IR, so there's no way you can find big letter R, because you do not know the sorry, you do not know the current, you do not know the V. So there's too many things that you don't know. Yeah. So V equals to IR cannot. Yeah. Don't know. So really there's no way. And actually there's an error in this question. They forgot to give the R value. Yeah, they forgot to give the R value. So how to do this? Quite bad lah, because like I said, they didn't did any correction or anything also. But don't go and leave it blank, because if you leave it blank, you get no marks. They won't give you bonus for this one. Objective maybe can, but structure they won't give you bonus one. If you never write anything, we assume you don't know. So you just do whatever you know. Yeah. So one of the ways is you can still go and find the current, but you leave the R as the unknown. Yeah. So you can factorize out the I from both, and what is left is R plus 2. And then the answer is 6 divided by R plus 2. Okay. The unit is in amperes. Okay. Okay. If you want to do this, you can also assume any R value. So for example, you can assume the R is equals to 1, R equals to 2. Any value also can. They will also accept. Some people say, since this one is 2, I also assume it's 2 lah. And I can show you how it works. We do like this. We're using this formula. e.m.f is 6. Everything is the same, just that big letter R is 2. And so I times 2 times plus I times 2. 2I plus 2I equals to 4I. 6 over 4 is the current, which is 1.5. Can also accepted. Okay. You can also assume another easier value. So any value you want, you can assume. But remember, just don't leave it blank. Yeah. So this question is in a way trying to teach us how do we deal with something like this if really SPM forget to give a value. Of course, you can ask the invigilator first. If the invigilator say got no correction, you have to try to write something. Don't leave it blank. Yeah. You can even assume that it's not there. You can even assume that it's just zero. Also, they accept. Okay. And it would be 0 times I, just 0, just 2i. Current is 6 over 2, which is 3. Anyone. You can assume any value also can. Calculation, okay, then okay. Yeah. So this is how you deal with something like that. Got mistake, you still have to write. You cannot leave it blank for structure, for essay also. Okay. Part C. The light produced by the torchlight is quite dim. You want you want to make modifications so that the torchlight can produce brighter light. Remember, your goal is to make it brighter, yeah? Number of batteries, of course, we want more. More batteries, you have more voltage, more e.m.f, right? You can say e.m.f increases. Do they accept the short form for e.m.f? Yes, because textbook also uses it. If you are paranoid, then you write the full name. Electromotive force increases. But e.m.f increases also means voltage increases. If the total supplied to your battery is higher, then you have more voltage to your bulb also. Or you want to add, then the current increases also can. Okay. Arrangement of batteries. For batteries, if you put in series, then you will make the bulb brighter. Because in series, the e.m.f will go up. Voltage go up also can. More e.m.f always means more voltage, or current increases also can. Please understand, if I got one battery, I got 3 batteries side by side. If every battery is 1 volt, 1 volt, 1 volt e.m.f, the total is equals to 3 volt. Right? You're going to get 3 volt. Because for a series circuit, voltage, we normally say voltage will share, right? But in this case, you think like the 3 volt share become 1, 1, 1. Or the 1, 1, 1 add together become 3. But if you do a battery in parallel, if each battery is 1 volt, 1 volt, 1 volt, the total you will get eventually is just 1 volt. Because why? In a parallel circuit, we always say the voltage is the same, right? So outside here 1 volt, inside here it's all 1 volt, 1 volt, 1. Or inside here all 1, 1, 1. Outside also you will only get 1. So if you connect a bulb to 3 volt versus you connect a bulb to 1 volt, of course 3 volt will be brighter. Okay. So that's why because the goal is to make it brighter, I want to put series. Yeah. Type of bulb. There's one type you all need to remember. LED. If they ask you what kind of bulb, you write LED. Reason, because LED is very energy saving. Or you want to say can save a lot of energy. But people ask, teacher, what if I forget LED bulb? Oh, then you write a energy saving bulb. Also can. But then the reason you write something else, maybe you can say there's gonna be less energy loss or less, and other than energy, you can also say less heat loss, right? Less power loss also can, or has higher efficiency, very high efficiency, meaning lose very little energy. LED is one of the best that you need to know at least one, which is LED. If you are thinking about, those older filament bulbs, maybe I need to use like, let's say just to give you an example, I need to use 80 watts for the filament bulb to give you the same brightness if I use just a 10 watt LED bulb. Both of them give me the same amount of brightness, but LED only requires 10 watts versus maybe the filament bulb requires 80 watts. So the energy difference is very high, but the brightness they give you is the same. You get what I mean? That's why we always prefer to choose LED. LED very, very energy saving. Yeah. Okay. Then question number 9, essay question. It's a 2 choose 1 section. You just have to choose one. But we'll go through both of them. Diagram 9 shows a construction worker handling a power driver machine at a construction site. A force is produced when the power driver hits the pile. Okay, the power driver is going to hit the pile. Usually we do this because we want to build very tall buildings. Yeah, and then we need very strong foundation in the ground. So it will hit, it will go into the ground. Okay, name the force acting on the pile in diagram 9.1. Impulsive force. When you hit, it's impulsive force, right? But they also accept if you go and say gravitational force, because it's the force acting downwards. The power is memang being put down by gravity, so that also makes sense. But I feel the best answer is impulsive. This year SPM, they did accept gravitation. They also accept. Okay, but I feel the best is this. But B, the workers must wear safety helmet in the construction area. Explain appropriate safety helmet features. Explain what are the features in the helmet to protect the worker's head from serious injury. Okay, 4 marks. So 4 marks feels a bit scary because you're just talking about the helmet. But remember, helmet has 2 parts. The outside of the helmet is very hard. The inside of the helmet is very soft. Okay, and then this is the person's head lah. Can So okay, so that's what you want to explain. Why is it hard? And why must it be soft? Honestly, the easier one is the soft part. The soft part you want to say because it reduces impulsive force, it increases the impact time, all of those things. Yeah. So I'm going to say, first of all, the inner lining is made of soft cushion, maybe. Or you just say the inner lining is soft, already correct. You don't want to say lining, you want to say, can I say the inner layer of the helmet? Teacher, I don't know the word lining, or I forgot the word lining, That's fine. As long as I can understand what you are trying to explain, then it's okay. Don't need to use complex English, it's fine. Keep it simple. I can understand what you're trying to say, then okay. The inner layer, okay. Okay, it's made of soft, can. Cushion also can. You want to say sponge, can. You want to say made of a cloth material, can. Rubber, latex, foam, polystyrene, okay. Okay, why must it be soft? Oh, because it is used to increase impact time. So that if anything fall my head, it will sink into my head with more impact time or reduce impulsive force. You can write both, but if you write either one already, you get 2 marks for the inner side. Then the outer layer of helmet is strong, hard, made of carbon fiber. Right? Reason, so that it does not break. It does not break easily during impact. It can withstand high force. That's it. Your answers don't have to be long and what, but I need you to be able to explain to me uh the important keywords. Impact time, impulsive force. All these are very, very important keywords. Can withstand a lot of force, can tahan a lot of force, won't break so easily. Yeah. Okay, so a bit scary lah for marks, but I think quite okay if you look at it like that. Part C, the table shows 4-power system, PQRS, used in the construction site area. I already have the table, the answer, so later we'll look at that together. Study the piling system, explain the suitability of each, determine the most suitable one. Okay. Height of power driver. Greater height will be better. Because if it's greater height, you can... By the way, those of you who don't know how a power driver works, it is like a hammer. Hammering a nail, hammer and a nail. You hammer this nail, go into the ground. Hammer, hammer, hammer a few times. You all know what hammer and nail is, right? Just in case. Okay, so you hammer, hammer, hammer the nail. Same thing. Use the power driver. You hammer, hammer, hammer. Hammer it into the ground. So when you lift it up higher a little bit and then you let it fall down, it is going to have more time to accelerate. It will have a greater speed, greater momentum, greater force as it falls down and hit. If it's... Guys, try to imagine if you're trying to hammer something with a very small distance. You don't just hammer a nail like that. You would hammer from the top and hammer down to get a big force. Same concept, no? That's why height has to be greater. Mass also has to be greater. But honestly, I think all these three are quite good. And also it has to be a sharp tip at the power. If it's sharp, then only it can poke into the ground, right? It can go into the ground deeper. If it's a flatter like this, it's a bit hard to go in. But honestly, for power material, it can also be both iron and concrete. Okay, it can be both iron or concrete. So what happened this year is that there's actually two correct answers. They accept both Q and R. Both also accepted. Okay, both also accepted. So like I said, this year got quite a few errors. Just now the calculation, they forgot to give the resistance. Objective question also got a question, they forgot to give some value. Yeah. And then here also got two answers. Okay, so I say, I want greater height. You please don't go and tell them, teacher, I want 12 meter. No, we do not write I want 12 meter. Don't need to teach them what to do. You can do 20 meter also can, as high as possible, so that you can produce a lot of momentum. If it's greater height, it will fall down even faster. By the time it falls down very fast. It produces a large impulsive force. Or the higher you are, the more gravitational potential energy. Or power can penetrate deeper. Okay, bigger mass. Again, I don't need to tell them I want 150 kg. I don't need to tell them I want 200 kg, right? But teacher, 150 is not the highest though. Is it okay if I say big? I want big mass, but I never choose the highest? Yeah, it's fine. It doesn't have to be the highest. High enough then can already. 200, 150, high enough then can already. It doesn't have to be the highest. Okay, but we do not write the number again. Just bigger mass, big mass, also can. Reason, produce a lot of momentum. Why? Because momentum is mass times velocity. Right? Just now you drop from a greater height, you increase the velocity. Then you increase the momentum. Now, greater mass, you also increase the momentum. Greater impulsive force, greater energy. Greater mass also got more inertia. You'll fall down, and it's harder to stop the motion. It will keep wanting to fall down, so it will hit with a greater force because there's very great inertia, and it will hit very hard. If you don't know what to say, you can also say power can penetrate deeper. Any one of the reason already correct. Okay, concrete or iron both accepted because they are both quite strong, does not break, can withstand high force. Okay. Sharp or pointed tip of the pile, I want it to be sharp. Why? Because if it's sharp, then the pressure is high. The surface area is smaller or can penetrate easily or deeper. Also can. Some people will say, teacher, will the force be higher if you have a shape like this? No, it's not. It's not to do with the force. It's something to do with the pressure. Because pressure is force over area. You make the tip become so sharp like this, the surface area right here is going to be small. Very small area. When the area is small, the pressure is going to become big. That means it will poke. Pressure meaning it's like it will poke onto that one point. All the force will concentrate on that one point. That's why it can poke through the ground. That's why it can go deeper. Okay, can penetrate deeper easily also can. You can say like that. Small area also can. Yeah. So if you write R is chosen, that is because you choose a concrete pile. If you say Q is chosen, that's because you choose an iron pile. Yeah, but the rest are all the same. That is how you can get your 10 marks. I feel if it was me, maybe I would choose concrete, no? Because the mass is greater, a lot greater. Right? I'll probably choose R if it was me. Yeah. You might think like, but concrete teacher will crack, huh? After you hit a few times. Yeah, that's true also. But usually concrete inside they will put some steel and all of that. Yeah, if they write like enforced concrete, then even better. I would definitely choose this. Enforced concrete, that means inside the concrete got enforced with some steel bars. Yeah, but iron also not bad. Okay, part D. Diagram shows a power driver, 450 kg, released from a stationary state. The time of motion of power driver just before the impact is 2 seconds. Calculate the velocity of the power driver just before the impact. Answer with a unit. Answer with a unit. Okay. This one you all can go and use your. I like to call this suvat. Because we know it is stationary at first, so the U value is 0. Okay, and then question asks, what is the V value just before it hit the power? And then they say the time is 2 seconds. And if a power driver so heavy fall down, the acceleration is 9.81. Right? You can call that the G value also. So looking at the formula sheet, you want to find something that doesn't have the S. Okay, I'll go to the formula sheet and I see this one, chapter 2, force and motion. Okay, something that doesn't have S. All this got S, I cannot use. I have to use number 1. V equals to U plus AT. Okay, let's try to solve. U is 0. A is 9.81. T is 2. You want to write G also can. A also can. Doesn't matter. Answer is going to be 19.62 meter per second. Okay. All right. That is answer for part 1. Answer with the unit. Okay, done. That is the unit. And then calculate the change of momentum of the power driver. Change of momentum, that means the mv minus the mu. Momentum is mass times velocity. But if you want to find the change, you always take the final momentum, final velocity, and initial momentum with the initial velocity. Just sub in 450 kg. V value is 19.62. U value is a 0. Anything times 0 is cancelled now. You don't have to do that. Okay, answer is 8829. Must have unit. Question someone reminded you already. This is kg. This one is meter per second. Just put together kg meter per second. Okay, that is the answer. 8829. Like that, 5 marks, eh? Not bad lah, right? Okay, not bad. And that is 20 marks in total for question number 9. Okay, a lot of people did this question. In fact, like 95% of students, they were doing this question because the next question is a bit more unexpected. That is question number 10. So why unexpected? Because one thing is many people didn't expect pressure that year to come out first thing. And also, even if they ask pressure, they ask something quite out of the box. They ask about a barometer, this 14 barometer. Okay, so how it works is that, of course, we use it to measure atmospheric pressure, but it works exactly as a usual mercury barometer where you got mercury level inside. Atmosphere is going to act on the surface and it's going to push the mercury level up to a different value depending on how strong the atmospheric pressure is. Okay, if the atmospheric pressure is stronger, it's going to push it higher. If it's weaker, it's going to push it lower. You also have a couple of scales to get the reading. Okay, and a bag to store the mercury. Usually it's a bag that is pretty flexible, and there's a screw level that you can adjust this bag. So this bag that contains the mercury. Remember, like I said, it's flexible, so you can adjust the screw to push the bag up higher or lower, depending on let's say let's say there's some error in the reading and you're trying to reset it. Okay, so this can help you to reset to the level that you want, the level that you know is correct. Part A, what is meant by atmospheric pressure? Okay. Atmospheric pressure exists because there is a lot of air acting on the earth. Let's say this is the earth. All this air is pressing on the earth's surface because of gravity. That's why you have this atmospheric pressure. It is the pressure caused by the weight of air layers acting on the earth's surface. Okay, but B1, explain why mercury is used in the glass tube of a 14 barometer. Okay, maybe I answer here. 3 marks. A lot of people don't know what to write for this one, but you can just think like, why do you want to use mercury for a thermometer? Okay, why do you want to use it for a thermometer? Same reason, why do you want to use it for a barometer? So one of the reason is because mercury is very dense. And because mercury is very dense, I do not need a very high level of mercury to give me the atmospheric pressure reading. You all must know as an SPM student that the atmospheric pressure is 76 cm of mercury. That means exactly, or rather, atmospheric pressure will push the mercury exactly 76 cm high. Okay, but do you know that if I go and use water, then I would need about 10.3 meter of water to get the exact same pressure. To get the exact same pressure. The reason is because the pressure is dependent on a couple of things, not just the height. Don't just think, but teacher, I thought greater height, rather greater depth means greater pressure. No, it also depends on the density. So if you have a very high density, then the liquid level don't have to be so high. Yeah. So that's one of the best reason why. I'm gonna say mercury has high density. So the height of barometer is shorter. It doesn't have to be like 10 meters high. If I use water, I need 10-meter long. Can you imagine? 10 meters like 5 or 6 story building like that. Yeah. Another thing is mercury does not stick to the glass wall. Just like for thermometer also, we do not want it to stick to the glass wall. Because if it sticks to the glass wall, then the mercury level is very hard to move because it's very sticky to the wall. You can also say does not stick to glass wall is because it has low adhesion force. That means it doesn't stick to the wall, or high sorry, I should spell it as adhesive force. High cohesive force. If you want to mention that also can. So low adhesion meaning low stickiness. Low stickiness. High cohesive force or high cohesion force means uh, sticks to itself very well. Cohesion or cohesive means they stick together very well so that it doesn't stick to the wall. Like water also. If you put a drop of water, you notice that the droplet of water is always like this. It sticks together because it has a very strong bond, hydrogen bond and all that, yeah, chemistry. When you put a drop of water, the water will not be flat like that. Yeah, so cohesion force means it sticks together, sticks to itself very well. While adhesion means stick to the wall. One is stick to outside, one is stick to itself. Okay, and then another thing is that mercury has quite a high boiling point. So it doesn't vaporize so easily. Does not vaporize easily. Okay, I feel even if you write halfway, like you just say mercury has high density, you never explain why, you can already get the mark. Yeah, mercury does not stick to the glass wall, can already get mark. Has high boiling point, can get mark already. Or mercury does not vaporize easily, can also get mark already. Yeah, but if you know more, it's always good to write lah. Like why is that and all. And also, mercury is opaque. Opaque, that means not transparent. Mercury is silver in color. Yeah, unlike water, water is transparent. Light can pass through the water droplet usually if I use water. But for mercury, because mercury is opaque, opaque that means not transparent, silver in color. So light cannot pass through. Light cannot penetrate. Or you can see very easily. You can see exactly where the mercury level is. Also one more, the meniscus of mercury is easy to read. For mercury, meniscus is this mercury level like that. This is the tube, this is the mercury. For mercury, the meniscus looks something like that. Like the meniscus, that curved part at the top of the mercury is very easy to read and it curves very uniformly. So you can just read the reading here like that. Yeah, this is for mercury. Mercury will curve like that at the top. Okay, got so many answers. You can write any three marks. And then for part 2, why is the vernier scale used in the 14 barometer? If you look in the picture, they didn't explain this in the textbook also, you know. They just put here got a vernier scale and then got a main scale. So you think like maybe the main scale is to give you because you want to measure how high, how many cm maybe. The main scale maybe give you like 1 cm, 2 cm, 3 cm, that kind of reading. But vernier scale always will help you to break it down. Like maybe give you the 0.1, 0.2, 0.3 cm kind of reading. It gives you the decimal point, maybe. Yeah, so vernier scale always helps you to break it down. The main scale gives you a bigger value. Just like, I don't know whether you all remember using vernier caliper in science last time or in physics also. Vernier caliper. Vernier scale comes from a vernier caliper also. Vernier caliper is to measure that reading also. Also the same concept. There's a main scale, vernier scale. So the keyword here, you just have to say it's going to make it more accurate. Yeah, it's going to make it more accurate. Because it breaks down the reading into smaller parts. So the mercury reading is accurate, is more accurate also can. That's why I use a vernier scale. Okay. Then we look at the assay. Again, I've given the answer, but we go through the table first. We got some characteristics of component used in a 14 barometer. You're required to study the characteristics of the 14 barometer. They just say use the most appropriate one to measure atmospheric pressure effectively. Give reason for your choice. 10 marks. Okay, the bag material. I will choose leather. Remember, the bag is to store mercury, right? Is to store mercury. Guys, we know that mercury is not like water, you know. Imagine you just use a plastic bag to go and store it, right? Mercury can be quite dangerous, and you want to make sure that it doesn't leak out or anything. And you must make sure that it can tahan for a long time. It can withstand and be long lasting. So therefore, use leather. Yeah, and the protector tube material, guys. If the tube is made of glass, would you agree that to protect a glass, I need to use some metal? Yeah, brass is a metal. I cannot choose a glass to protect another glass. So maybe there's this really long tube. You see inside, there's a really long tube, and then there's an outer layer of metal to protect it so that it won't break so easily. Very strong. And the pointer material is actually made of ivory. Okay. Ivory, is made of the elephant tusk. It's illegal these days because of animal cruelty and all that. But the elephant tusk. Yeah, that thing is made of ivory. Why do they use that? Especially older barometers, because we found out that it doesn't react with the mercury. It's non-reactive to mercury. But these days, other than ivory, you can also use materials like a very good kind of plastic or glass also can, because those kind of any material that doesn't react with mercury, then okay. If you put a metal mixed with mercury is also a metal, it can be quite corrosive. Yeah, so I want to make sure that this pointer material don't react with the mercury. Okay, the pointer is to tell exactly where the mercury level should be. Yeah, it must always be right at the pointer there. If it's too low or too high, you can always adjust the screw to push the bag of mercury up or down to make sure that whatever you are measuring is an accurate value. Yeah, you must always be at this pointer, and you start from here all the way up here. You measure that height. Last one, any additional instrument that you want to add. We're going to add a hydrometer, sorry, a thermometer to measure temperature. We know that temperature and pressure, just like when you learn your gas laws, temperature and pressure and volume, these three things are related. In this case, also the same. If you know the pressure of your atmosphere, and then you also know the temperature of your surrounding, you can relate these two things, because temperature and pressure, they are related, of your atmosphere. Yeah, they're related. A hydrometer is to measure density of liquid. Definitely wrong. Right? So a lot of people, they don't really know what to choose for this one. But the clear winner is going to be Q. Okay, the clear winner is going to be Q. Let's take a look how we write. I want leather as the back material, because leather very strong and flexible, does not tear easily. I want brass as the protector tube material. Very strong to protect the glass tube, does not break easily. I want to choose ivory, because remember I say you can choose anything that don't react with mercury. Mercury can be quite corrosive. Yeah, does not rust also. Ivory, it is chemically not reactive, or chemically inert also can. Inert, that means it doesn't react with anything. Last one, I use thermometer as additional instrument. You can see something very simple. To measure temperature, again, to determine the pressures at different temperatures, because we know temperature will affect pressure. So you can relate these two things, and to able to relate pressure with temperature also can. So you can keep it simple, to measure temperature. Fine. And at last, Q is chosen because it has leatherback material, brass protected tube material, ivory as pointer material, and thermometer as additional equipment. 10 marks. This is why we want to choose Q. Okay, 1, 2, 3, 4. 1, 2, 3, 4. Any one reason already correct. You don't have to write so many. But can you write 2 reason if you want? Can. Can you write 3 reason if you want? Can. Writing more is not a problem. Yeah. And then you chose Q, and the reason why, that is 10 out of 10. Okay, so quite a special question, this one. At least we tried before. A lot of people avoided this question because they don't know what is going on with here. Most people just chose the easier one, the power driver question. Okay. Part D. The atmospheric pressure on the surface of the sea is 76 cm Hg. Hg means mercury. Atmospheric pressure at the top of the mountain is 30 cm Hg. Density of mercury is this. Average density of air is this. Calculate the atmospheric pressure at sea level in the unit of millibar. Okay, they did tell you that millibar is 1 HPA. A lot of people don't know that H actually stands for hectopascal. Hecto, H-E-C-T-O, which means 100 or 10 to the power of 2. It's just like, you know how kilo is 1,000 or 10 to the power of 3? Yeah, hecto is like that. Okay, so number 1, atmospheric pressure at sea level. At sea level, it is 76 cm Hg. You want to change to Pascal first, then from Pascal, you change to millibar. Now, I don't know whether you all know or not. Every time you want to change the height to Pascal or Pascal to height, you always use this formula, this liquid pressure formula. This is the height or the depth. This one, or rather I straight away make it clearer. This is your cm, your how many meter, how many mm of Hg, H2O, whatever. And this must always be Pascal. You want to find Pascal means you want to find the P. Yeah. So you submit these 3 things. But you have to be careful. You have to use SI unit. If you want to get Pascal, you have to use SI unit. So like cm, if you got cm, you change to meter. If you got mm, also you change to meter. So that is 0.76 meter of mercury. Density of mercury is 1.36. Everything here is mercury. Kg is SI unit. Meter cube also SI unit. Then the G value also you use SI unit. By doing this, you will already get 2 marks. Out of 3 marks, you already get 2 marks. Okay, the last job is you need to change to millibar. Millibar, the unit. In order to change that, you first need to change to hectopascal. So you want to ask yourself, how do we change this to a times 10 to the power of 2? Okay. See guys. If I want to add a hecto times 10 to the power of 2, I need to make sure I move 2 decimal place in. I repeat, if you want to make 2 decimal place bigger, you must make sure the number here, you make 2 decimal place smaller. 2 decimal place bigger, 2 decimal place smaller. Why? You cannot change the value. It must be this value. Yeah, the value is, the answer is already there. You cannot change the number. It must be 101,396.16. I repeat, here, make 2 decimal place bigger. Here, you have to make 2 decimal place smaller. Okay, and what is 10 to the power of 2 and PA like this? It means hectopascal, which also means it is your answer already. How many millibar? This is how you get 3 marks. Yeah, but the difficult part, or rather the part that is most marks, is 2 marks here. Yeah, I feel like here I know a bit tricky, but here only 1 mark. So if you don't want, teacher, if I don't want to do all this working, I straight away know it's like this, can or not? Can also? If you know straight away, you can jump there straight, because it's just like these 3 marks. Yeah, okay, but this is something that a lot of people don't know maybe, huh? Okay, part 2, calculate the height of the mountain in the unit of meter. A bit tricky this one. Honestly, I feel part 2 is more difficult. This is a mountain, by the way. At the bottom of the mountain, they say the pressure is 76 cm Hg. At the top of the mountain, they say the pressure is 30 cm Hg. Okay, now how do you find the height of the mountain? You first need to go and find out what is the pressure difference. The pressure difference will give you the height difference. 76 minus 30. That is the pressure difference. Now your next job is to go and change this pressure difference to a height difference, but I want in meter of air. If you can get this answer, you are done already. This is the answer I want. So a lot of people will be saying, teacher, why you go and find the pressure difference? Why not you just go and find out the pressure for this guy, right? And the pressure for this guy. No, you cannot do like that. You must understand what is going on here is, imagine I have a barometer between the top and the bottom, but this whole barometer now, I want to fill it with air inside. Yeah, when this barometer is filled with air, the question is, how much air do you need? Because outside of the mountain is all air, right? But the question is, here you got pressure already, here you got pressure already. How much air do you need to give you that height difference? I always tell my students, height difference and pressure difference, they are related one. If you know the height difference, you can also find the pressure difference. You know the pressure difference between here and here. You can also find out what is the height difference at the bottom and at the top. I want to find that height of air between the bottom and the top there. Okay, so one of the ways is this way. Another way is some people will say, teacher, can I find out what is the how many meter of air here and how many meter of air here? And then only I minus. Can also, you want to minus later or before, it doesn't matter. But your idea must be here. You must know that understanding and finding out the pressure difference will always give you the height difference from the bottom and the top of the mountain. Okay, and how do we change cmHg to meter of air? You have to use the formula. But remember, right now you want to sub in 46 cmHg. Pascal will always give you what? Sorry, P will always give you Pascal. Huh? That's what I wanted to ask. Now P will always give you Pascal. So you go and find first. I changed to meter. This is mercury, so you use the density of mercury 1.36. The G value 9.81. Multiply and you will get 61371.36 Pascal. Okay, then remember, I'm going to use the formula one more time. But now I want to change to how many meter of air. Just now all these things is for mercury. Now all these things is for air. Okay, now later I want to find the height of air. But what is the value in Pascal? The value in Pascal is 61371.36. You want to find the height of air. Density of air is 1.3. G value, 9.81. Okay, so you divide everything over, you can find out what is the H. Answer is 4812.308 meters. That is the answer. Okay, to those of you who are feeling a bit confused, please know that 46 cm of mercury is exactly the same as 61371.36 Pascal, which is exactly the same as 4812.308 meter of air, which is the height of your mountain, because to measure the height, you measure it in air. Yeah, so this question is actually very K-but. A lot of students cannot do this because they maybe are not very strong with the idea of the pressure difference and the height difference is related. Yeah, and also maybe if you're not very confident at converting the units, then it can be a problem as well. That means, you know what this means or not? You take 46 cm of mercury, the mercury will press and give you some pressure, right? This pressure is exactly the same as if you go and take air, but you have to use 4812.308 meters of air to give you the exact same amount of pressure, because air will also press and give you pressure. How much pressure it press and give you? Of course, you need a lot of air to give you the same amount of pressure as just 46 cm of mercury, because mercury is very heavy, very dense, while air is very light. That's why you got such a big difference in height. Yeah. Okay. Next question 10. Last one. Question 11. Compulsory question. The diagram shows half-life of a graph for radioisotope X and Y. What is meant by half-life? Half-life is the time that it will become half the original mass or half the original number. Time taken for a sample of radioactive nuclei. To decay to half of its initial can, original number also can. All right, initial. Okay, so if it keeps on becoming more and more and more stable, something that is very radioactive will always try to find a way to be more stable. The time taken for it to become more stable by making the original number of unstable one become half of the unstable one. At first, I got 100 unstable one, but at the half-life, I will only have 50 unstable one. That is what half-life is. To decay from 100 to 50. What is that time taken? Okay, but B, observe the diagram, compare the number of original nuclei, half-life, and also the decay rate between radioisotope X and Y. Okay, for this question, and then they ask you to relate. Okay, for this question, there's a big issue. Many students complained it because during that year, they did not label X and Y. You look at the graph, you do not know which one is X and which one is Y. So many students, they panic. That's why 2023 was a pretty bad paper in a way that there's many errors. Yeah. So what to do? If you leave blank, you get 5 marks, 0 out of 5 marks. There's no bonus marks. You have to either write the top here X or the bottom here X. You choose. You decide yourself and you write. There's no correction also during that year. So up to you. My answer right now, I'm going to do for on top is X, down there is Y. But you can also write yourself. Up there Y, down there X. Up to you. The examiners will mark according to your label. Okay, so this is what I meant by structure question. You do not need to copy the number of original nuclei. You don't need to copy. But essay question, you have to copy. And I already write lah, the number of original nuclei of radioisotope X and Y is the same. You can put equal sign. How I know it's the same? Because they both started with the same number at the top. Okay, and it will slowly fall down. Next one is the half-life of radioisotope. For X, the half-life is much longer. For Y, the half-life is much shorter. Half-life is the time taken for it to cut down to half, to become half the number, which is here and here. So X, for my graph, for my labeling, X is longer, Y is shorter. X is longer than Y. The decay rate means how fast it decay, how fast it fall down. Can you see that the graph for Y fall down very fast, decays very fast? Yeah, falls down very fast. So Y is faster or higher rate of decay. Decay meaning fall down faster. Okay. X is lower rate now. So you can say X is lower than Y. You can write in words also. Or in SPM, you can write exactly like that. Must write the whole thing. You must write out what are you comparing. Number of original nuclei, half-life, decay rate. Okay, the fourth one, they ask you, relate the number of original nuclei with the half-life. Do you notice the original number doesn't affect the half-life? It's the type of radioisotope itself that controls how fast it decays. So the original number don't affect. There's no relationship. You just say, does not affect. Okay, quite special because normally relationship we like to say like, oh, the greater, the smaller, that kind of answer, right? This one does not affect. Last one, deduce relationship between half-life and decay rate. Okay, you can look at your answer here. Half-life for X is greater, decay rate of X is smaller. The greater, the smaller. One bigger, one smaller. The greater or the longer the half-life also can. Then the lower the decay rate. Or as the half-life increases, the decay rate decreases. Also okay. Yeah. For rate, I like to say lower or higher. You don't say faster or slower rate. We don't say that. Yeah. Rate always high or low. Okay, part C. Radioisotope Y experience nuclear fission and produce a lot of nuclear energy. Explain why the nuclear energy can be produced during nuclear fission process. Explain why got energy. In case you have forgotten, nuclear fission means the splitting of nucleus. Yeah, you got a very heavy nucleus. You bombard it with some neutron, and it's going to split up into smaller and lighter nuclei. Okay, and at the same time, it's going to release more neutrons. The neutrons will continue to go and bombard other uranium. So usually all these are uranium. Okay, for example, but right now they just say it's radioisotope Y, and it will keep going on. And it can produce a lot of energy. But ask yourself, why got energy? And that one answer is because there is mass defect. As time goes by, there's always going to be mass loss. If you go and take the total mass of all these things, and the total mass of all these things is not the same one. There's going to be some mass that suddenly go missing. Mass lost. We call it mass defect. Albert Einstein has found out that the reason why your mass lost is because the mass converted itself to some energy. The mass that disappeared became energy. And it is related using this formula E equals to mc squared. When you lose more mass, you get more energy. Okay, so this is the whole story lah. Now we're going to try to write the explanation. The reason why got energy is because there is mass defect. You write the word mass defect, you already get 1 mark. Or you can say mass defect produces the energy. And how do you find the mass defect? You take how to find mass loss, total mass before nuclear fission. Or maybe I wanted to say to find mass defect, you have to minus, but maybe I go and explain further first. Total mass before nuclear fission is greater than total mass after nuclear fission. Okay. And then there is mass loss during the process, or mass reduce during nuclear fission. Like that, you already get 3 marks. And then got mass defect. And then you can also go and say, to find out the mass defect, you can write in equation form like how I'm writing, you will get mark. Or you want to write in words also can. You have to subtract total mass before nuclear fission. And then you need to minus the total mass after the fission. You write this formula, how to get the mass defect, you get another mark. You know what? You will also get mark if you go and write E equals to mc squared to show them how mass defects relate to energy. Okay, maybe I add one more time and say mass defect converts to large amount of nuclear energy. The whole idea is just around mass defect. If you notice, mass loss, you get a mark. How to get the mass defect? You get a mark. You say the before is greater than after, you get mark. Yeah, formula you get mark. You say mass defect converts to energy, also get mark. So any 4 out of 5 points, the whole question is just about mass defect. Okay? Got people go and answer about like chain reaction and all of those things. I don't think you need to. Yeah. How to get energy because of mass defect. Yeah, but 4 marks is very scary. So you just really write whatever you know. And it's a compulsory question, so you can't escape. And then we got one last part to end the paper, just 10 marks. Okay, the government proposed that we use nuclear energy to generate electricity to solve energy crisis problem in industrial area. You as a scientist needs to conduct some research, make recommendation to structural aspects of the nuclear reactor. Okay, electric current generators that are suitable to use so that nuclear energy and electricity produced are sufficient and safe to use. Sufficient means got enough energy. Explain your answer involving aspects of nuclear reactor wall thickness, type of radioisotope use, nuclear reactor safety, turbines and solenoids in the electric current generator, Okay, so a lot of people were very scared because why suddenly nuclear physics got solenoid and turbine one? Right? They're just there trying to make you panic only. Okay, because the answers for a nuclear reactor is really very standard. To talk about wall thickness, of course, you want a greater thickness of wall. The thicker the wall, the more you can avoid leakage of radiation. I like this answer as the reason. You can also say to avoid radiation released to the surrounding, to the environment. Can also. And normally we like to use thick concrete to block off the radiation. And when I say radiation, I'm talking about your alpha, beta, gamma radiation. Because if you got a lot of alpha, beta, gamma and exposed to human body, then you will hear things like, oh, the human body uh, will be mutated, and then you get birth defects, yeah, and then the child that is born maybe will have some disabilities is because of the radiation, the alpha, beta, and gamma, yeah, okay, and then type of radioisotope got many things to say. Long half-life. If long half-life, don't need to keep replacing. Very long lasting. A long half-life, for example, uranium, means that it can stay as uranium for very, very long time. Uranium doesn't really become other things because it takes so long to decay to other things. So it's like, okay, I have a reactor full of uranium. When I need to use it, the uranium is still there. It's like, or else when I want to use the uranium and then I realize the uranium is not there anymore because uranium may be already converted to other things. But that won't really happen if your half-life is very, very long. It stays as uranium for a long time. So it is there for you to react with it, to have nuclear fission. I want a solid usually because very easy to handle. You want to remove the rod and replace it, you just pull it out because it's solid. If it's liquid, then it's very messy. You have to pour out, pour in. If it's gas, even worse, right? Will not spill. Normally we use uranium, sometimes plutonium also, because it has long half-life, can have nuclear fission, has a very big mass. Very big mass, that's why it can have fission reaction. Chain reaction can occur because again, it has very big mass, uranium very big. The mass number is 236 usually, and can produce a lot of energy. That's why we love uranium. Okay, other than that, they ask also about nuclear reactor safety. Usually, this comes down to your moderator, your control rod, and your cooling agent. These three are safety feature. Normally, they can control the rate of reaction. Okay, we use boron or cadmium because control rod always helps to absorb excess neutrons. This is the best reason. You can say control rate of reaction, control chain reaction also. Graphite moderator. Moderator always to slow down neutrons. For my students, particularly that year, they were very happy because I taught them how to remember. I always say, boron cadmium control rod is to absorb. Graphite moderator is to slow down. People always mix up these two. If you change the position then wrong already, I tell them, you buy CD to control AirPods. I know it sounds funny and it doesn't make sense, but B stands for boron. CD is the symbol for cadmium. Control is control rod. The letter A is to tell you is to absorb. Because people always mix up which one absorb and which one slow down. Which one is boron? Is it control rod or is it moderator? And then for graphite, I like to tell them, you can think slow mo graph. Again, I know it doesn't make sense, but really I've tested it many years and students always remember very well. Graphite, this one I have to read backwards. Graphite, moderator, the job is to slow down neutrons. One is to absorb neutrons, one is to slow it down. Graphite, moderator, to slow down neutrons. Yeah, so these two, make sure you know, they're quite popular also in structure questions. Water as cooling agent. Water has high specific heat capacity, can absorb a lot of heat. I want a low density turbine. They also ask about the turbine and the solenoid. Actually, this one is giving you extra points, Honestly speaking, the nuclear reactor already got a lot of things to say and they're really very kind. They're giving you more things to talk about, 10 marks. You can also talk about anything related to generator. That means your electromagnetism concept. I use a lighter turbine. Turbine can spin faster, got low mass, lighter, smaller inertia. The faster you spin, the faster the magnet will spin or the coil will spin, the more electricity you're going to generate, the more induced current you're going to get. Yeah, thicker wire, low resistance. Copper wire, low resistance, low resistivity. I want a big turbine, can spin more and cut more magnetic flux, produce more induced current, produce more induced e.m.f, has very high voltage. I want more number of turns of the coil in the solenoid. I coil many times, I can cut more flux, produce more current, produce more e.m.f, right? So they're kind because they give you 2 chapters to talk about in these landmarks, and you see there's so many things that are possible answers. I think you can get like 20 marks also if they give you 20. Yeah. So any 5 modification and 5 good reason, already full mark. That is the end of SPM 2023 paper. I think it's quite okay, this one. Only thing they forget to label the X and Y. But for you, I think you will know how to deal with this kind of correction later on. Remember, don't leave it blank. Try to answer. Even if it means you need to assume a few things. Label yourself if you need to. Don't leave it blank. There's no bonus. Okay, all the best. I'll see you in the next one. Huh? Right. Sorry for the very bad cough today and very itchy throat. I hope it doesn't affect it too much. Okay, see you guys.